Welcome. In this video, we're going to demonstrate where these functions are continuous and demonstrate where they are not continuous. And these are both functions of two variables. Recall that in order for this function to be continuous, then the following have to hold. And this is a little off to the edge, so let me scooch that over here. There we are. So the first condition, and actually I'm missing something. This is continuous at the point A comma B if, now I can do this, my first condition, f of A comma B exists, the limit as x comma y approaches A comma B of f of x comma y equals A comma B. Oh, excuse me, that's the third condition. This also exists. And the third condition is that these are the same. That is, the limit as x comma y approaches A comma B of f of x comma y has to equal A comma B. Now let's go ahead and demonstrate this for the first one at the point negative 2 comma 6. So the first condition, let's go ahead and put in negative 2 for x and 6 for y. That gives me 3 times negative 2 squared over 6, which is 3 times 4 over 6, and that's just 2. My second condition, the limit as x comma y approaches negative 2 comma 6 of 3x squared over y, well, that's also going to be 3 times negative 2 squared over 6, which is 2. So, of course, by 1 and 2, the limit as xy approaches AB of f of xy, in this case AB is negative 2, 6, does equal AB, so this function is continuous. And this function is continuous specifically at negative 2 comma 6. Okay, now let's look at this for the point 0, 0. So first, let's try to evaluate f of 0, 0. That would be 3 times 0 squared over 0. And unfortunately, this is 0 over 0. Division by 0 is undefined. So we can stop now since condition 1 fails. So this limit doesn't, this function here is not continuous at 0, 0. Okay, so now let's look at this for g. And I'm going to start by looking at the point 1 comma pi over 2. So let's start by evaluating g at 1 comma pi over 2. This is 1 squared times tangent. Oh, excuse me, that's not 1 squared. Y is pi over 2. That's pi over 2 squared times tangent of 1. And tangent of 1 is like, what is that, 1 and change, 1.5 something, almost 1.6. And pi squared over 4, let me just write this out real fast. Pi squared over 4 times tangent of 1. All of this is defined, so condition 1 holds. Let's look at condition 2. That is the limit as x comma y approaches 1 comma pi over 2 of y squared tangent of x. Well, that again is going to be pi squared over 4 times tangent of 1. So again, by 1 and 2, the limit is x comma y approaches a comma b of g, in this case of x comma y, is equal to a comma b. So I know that g of x comma y is continuous at 0.1 comma pi over 2. Now let's look at this for the point pi over 2 comma 1. So g of pi over 2 comma 1, this is the first condition we're looking at here to see if the function exists at that point. Well, this is going to be y is 1. So now I have 1 squared tangent of pi over 2. And in case your trig is rusty, I'll rewrite this one more time. Maybe once more. This is sine of pi over 2 is 1. Cosine of pi over 2 is 0. Again, this is division by 0. So this function, g of x comma y, is discontinuous at the point pi over 2 comma 1. Hopefully you found this video beneficial. Please keep calm and math on.